Hello everyone. In this video, we are going to study an important method to solve non-homogeneous differential equations. This method is known as variation of parameters. So far, we have learned how to solve homogeneous differential equations and find the complementary function. But in many real-world problems, the equations are non-homogeneous and finding a particular solution becomes essential. This where the method of variation of parameters come into play. The basic idea behind this method is quite interesting. Instead of treating constant as fixed values, we allow them to vary as functions of the independent variable. Using this approach, we can construct a particular solution and hence obtain the complete solution of the differential equation. In this session, we will understand concept behind the method, learn the step-by-step procedure, solve a numerical example, and discuss important tips for solving problems efficiently. By the end of this video, we will be able to confidently apply this method in your exams. Let's get started. Suppose they have given a differential equation like this: y double dash plus y is equal to sec x. So the RHS of this differential equation is not equal to 0. It means that the given differential equation is non-homogeneous. So what are the steps here? First, you need to solve homogeneous equation. It means that we have to consider RHS of this differential equation as 0. If the RHS is 0, then we are going to call the given differential equation as a homogeneous equation. After that, we need to find the complementary function. For that, we require auxiliary equation. We will see the steps how to find auxiliary equation. After this, we need to identify what is y1 and y2, because suppose this is a second order differential equation, then the complementary function is c1 y1 plus c2 y2. So here y1 and y2, they are the functions of x. After this, we need to find Wronskian, which is a determinant. First row is y1 and y2, and second row is y1 dash and y2 dash. They are the derivatives of y1 and y2 respectively. And the value of this determinant should not be equal to 0. Means it should be a non-zero matrix. If the value of W is not equal to 0, then we can apply method of variation of parameters. In the next step, we need to assume that particular integral, that is yp, is equal to u1 x into y1 plus u2 x into y2. We are going to consider this is your particular integral. We will assume that yp is equal to u1x into y1 plus u2x into y2. We have replaced this c1 and c2 in complementary function with y1x and y2x. Then we need to use the formula to find u1 and u2. After finding u1 and u2, we are going to substitute in this equation yp is equal to u1x into y1 plus u2x into y2. Then we will write the general solution General solution is complementary function plus particular integral, and we will simplify at the end. So this is a procedure to solve any non-homogeneous differential equation using variation of parameters. Now we are going to solve the same equation in detail. This is the given equation: y double dash plus y is equal to sec x. First step is we need to find the complementary function, which is CF. So we need to solve the homogeneous equation. Homogeneous equation means right hand side is 0. This equation we need to solve. What will be the auxiliary equation? Because y double dash is d2 square y upon dx square, or we can write in short d square y also. So this equation can be expressed in the form d square plus 1 into y is equal to 0. So the corresponding auxiliary equation is m square plus 1 is equal to 0. We can find the roots of this equation: m square equal to minus 1, or we may write m is equal to plus or minus I. Now we have to write the complementary function. So complementary function is yc is equal to c1. Here roots are complex number c1 cos x plus c2 sin x. So this is the complementary function. Now we have to identify y1 and y2. So for that I'm going to compare c1 y1 plus c2 y2. So we will come to know here y1 is equal to cos x and y2 is equal to sin x. We have to compute Wronskian now. We know that what is meant by Wronskian and how to calculate it. This is a determinant. First row is y1, y2. Second row is y1 dash and y2 dash, their respective derivatives. y1 is cos x, y2 is sin x, its derivative with respect to x is minus sin x, and derivative of sin x is cos x. If you simplify this determinant, which is cos square x plus sin square x, and by using trigonometric identities, its value is 1. So here we have calculated Wronskian. Now we have to consider particular integral. So I'm going to consider particular integral as yp is equal to c1. Instead of c1, I'm going to write now u1, right? u1 of x into y1 plus u2 of x into y2. This is particular integral. Now we have to find u1 of x and u2 of x. So the formula to calculate u1 of x is equal to integral minus y2 into capital X upon w into dx minus y2. Here value of y2 is sin x, and capital X is the right hand side of the given differential equation, which is sec x into dx. So this is minus integration of tan x into dx, and we know that the integration of tan x is log of, or in fact minus tan x is there. So it is log of cos x. So this is the value of u1. Similarly, we are going to calculate u2 also. So the formula to calculate u2 is equal to u2 of x is equal to integral y1 into x upon w into dx. Here the value of y1 is cos x. Right hand side of the given differential equation is sec x upon w is 1 into dx. So cos x into sec x is 1 into dx, and integration of 1 is x only. So the value of u2 of x is x. Now we have to substitute these values in yp. So we can write yp is equal to u1, which is log of cos x. In fact, you can write on mod, log of mod of cos x, into y1. Value of y1 is cos x, plus u2 of x is x, into y2 of x, which is equal to sine x. So this is the value of y2. At the end, we are going to write the general equation, which is y equal to yc plus yp. Therefore, y is equal to yc, means complementary function, which is c1 cos x plus c2 sin x, plus the yp part, which is log of mod of cos x into cos x plus x into sin x. Thank you.